How's it, and welcome back to another tutorial. This one I'm just gonna give you a run through of my Raspberry Bubbles post that I made. It's gonna just be a run through of the scene file, and I'll explain the nodes along the way. But it's gonna be broken down into three sections. We're gonna have the initial flip sim, which will be quite like a low-res sim, and that will we'll use the velocity field from that simulation to drive a Vellum sim, and then on top of that Vellum sim we'll just do a high-res flip sim, and then we'll put them on top of each other and we'll get the effect that you guys saw in the video. So let's get started. I'm just going to jump into this initial setup and give you a little overview of what it looks like, and we're going to start with the emitter, which is just a primitive sphere. And I've just added some noise on the X and the Z, so that just a little bit of movement on that emitter, because otherwise, if it's just stationary, it's kind of not as exciting. And then I've also just scaled it down towards where I want the liquid to finish. You can see over here towards the end, it just tapers down, which will just give the liquid a nice feel, a better feel when it stops emitting. And then I've put a delete node down, which deletes by expression, and it deletes when the frames are bigger than 125. So we'll see that it's around here, and then at frame 125, it just disappears because the expression evaluates to a 1. And back here before 125, the expression is 0, so it's not going to delete anything. And put a null here. I'm going to call that out emitter, so we can just reference that later, because I want the particle separation to be quite low for this one, but for the higher res one, I want to use the same emitter, but I want a higher particle separation. So I've done the null over here instead of doing it down here. And then we've got a points from volume, which just creates our particles, and I've put a particle separation of 0.01. I've jittered the seed $FF, which is a floating frame, so every single frame and between each frame you'll have a different seed, and the jitter scales on 1 as well. If I put that to 0, you can see it's quite uniform. So the jitter scales on 1, and then at the bottom here I've created an output group called particles, and I've named it particles because if you just select this, it'll say nothing here, so just write in particles, and that will be for our flip to initialize. It needs a group called particles in the points. So for middle mouse button here, we've got a group called particles, which is what we want. So we play this now, we can just see our points going crazy, which is what we need. All right, and then on this side, I've got a collision, which is just a bigger sphere. It's a polygon and frequency of 10. And then I've subdivided it. I could have just upped that frequency, but I just dropped a subdiv. Put it at 2. Yeah. And then I've put a collision source down. Collision source will set up our geo on the one end, and out the other side it gives you a VDB, which we'll use in the flip sim. So on the volume side, I've just linked the particle separation from over here. I've just copied that parameter, right click copy parameter, and I've just pasted it over here so that we have the voxel size is linked to the particle separation, and everything else I left default. And then I put a DOP-net down, and I've piped in the particles into the first input. Into the second input, I've piped in the geo, and into the third input, I've piped in the VDB. So you can see the VDB here, and that's the geometry. And all right, so if we dive into here, it's just a flip object, a volume source, a flip solver, merging in the object, the static object, a gravity, and output. I'll talk you through it from the bottom up. So we've got a gravity, which is just left default, and then I've got a merge, and I'm merging in this collision geo, And to do that, I've just done an expression, op input path. And this looks at the incoming geometry, and then which is this guy here, and then which port are we looking at. So I want to look at the second, so which is input number 1, and you just evaluate that expression like that. You middle mouse on it, it shows you what it's looking for, which is great because this is the collision source, and that brings in the geo. And then further down here, under collisions and the volume tab, I've set it to volume sample, and for the proxy volume I've just pasted that same op input path, but I've just changed it to the second input, the third input, which is number 2, which is the VDB. So that's all set up now. Then on the flip solver, I've got sub-steps I've left the same, particle motion, everything was default here. Reseeding I turned off. Separation, I've added separation, left it defaults. Separation just gives the particles even distance between them, which helps. I find it just helps a little bit with meshing. I mean, it's not really necessary right now because we're just looking for a field, but yeah, just kind of by habit, I think. And then volume motion, I've put it to swirly. Splashy is more for bigger scenes and oceans. And then volume limits, I've just changed the scale of my volume limits just so that it keeps it at a smaller scale here. Comes in at like 50 and 50-50, which is just really big. And viscosity, I've enabled viscosity, and surface tension at a value of 1. And that's everything on the flip solver. On the flip object, I've pasted that same particle separation from out here, that guy, and put it there. And then initial data, I've changed that to a particle field, and I've cleaned out the soft path. And in guides, I've changed the visualization. I think it's sprites, which is this blobby mess here. I've just changed the particles. And then physical, I've changed the density to 100 and the viscosity to 1. All right. And then the volume source, which goes into the sourcing here, this last input, I've just chosen flip source flip, and then I've chosen first context geometry. And then it just sources, it sets it up for you. So it puts in this over here, and it also sets up this. And this is where the group here we created earlier on the points volume, I created this group particles because the volume source is looking for a group called particles. If we don't have that group, we have no particles. So that's that set up. So obviously if we just play this now, we've got a pretty low res sim playing back quite quick on the viewport. Looking good. Getting some nice kind of wavy behavior here, which is quite nice. So that's great. And on the next thing I do, I just drop down a .io. So this one, .io, because there's also a .dop import, also this one. But make sure you choose the .io, and then I just drag. You can just, because this is like that. So you can just drag the .net into that, and then I go and I grab the flip object and just Control C on that, and then on the .io just Control V that, and I paste that node into the .dop node, and then over here the preset I just choose FLIP Fluid, and then it sets up all these things for you as well. And then that way we just get the particles and we don't get from here we're getting the collision. Over here it just sends out the particles. And then I drop down a fluid compress node, and I just paste in that same particle separation over here before I bake that out. So I'm going to cache this out with the file cache, which is what you should do. And you'll just set your file path wherever you want it. And this fluid compress just basically packs all the particles into these tiles. So if you middle mouse button, you can see it's packed geos with 31 packed geos, and then each of these packed tiles have particles inside of them. It just compresses it for saving to disk, which really helps on the file size. If you have a really high res sim, this can save a lot of disk space, so highly recommend. I never used to do this, and I always was running out of disk space, so drop this fluid compress down. It's a bit of a game changer for saving space. And then I just drop down a null, call it up vel, so we can source that in to our Vellum sim. So that's that done. Let's jump into the Vellum side of things. All right, so on the Vellum side of things, I want to create these little spheres on top of that collision geometry, so that when the liquid falls onto that collision geometry, it can push those spheres around and push them down over the sphere. And so basically I just created a grid and left it just, just changed the scale down to 1 to 1. And then I scattered some points on that. And then I dropped down an attribute randomize, and I called it p scale, and I set this to 1 and just put my min and max values in here, which just puts an attribute on every single scattered point called p scale. If we look at the geometry spreadsheet, we can see it's got random values between 0.01 and 0.05 on every single point. And then I have a sphere, and then the copy to points, sphere goes into the left, the points go into the right, and then this copy to points node picks up the p scale attribute on every single point, and it scales each sphere down to those points. And then what I did after this, I realized that I could have done this a different way, and I'll show you a different way of doing it, but I did see some cool behavior out of this, so I'm just going to show it to you quick, and then I'll show you the other way of doing it. Next, I dropped down a Vellum tetrahedral configure soft body, which drops down the solid conform for us and the tetrahedral Vellum constraint. So that's what this is, these two nodes. I left everything at default here for the solid conform, which basically just turns these spheres into little solid spheres. So if we look at, let's do a clip and do a clip on these, you can see that there's actually geometry inside. It's creating solid spheres. It's drawing polygons inside of these spheres, which is wonderful for us because you can see there. Oh, there you go. It's creating like this like net of polygons inside each sphere, which will create these like internal spring structures for these spheres, which will make them look quite organic, kind of like Fem, but Vellum Fem. And so then I put down I didn't put it down. It gets dropped down and it creates these constraints for us. Preserve volume, I think I ticked that, and that's all fine. And I changed the edge length to 0.05, density to 100, stretch damping ratio to 0.01. Yeah. And then I piped in, I object merged the out collider geo from the initial setup into here, and I piped that into the collision geometry input, and then I dropped down a Vellum solver, just the shelf Vellum solver, and piped all three. And I don't think I did anything fancy here. I didn't have any gravity. I chose to have no gravity, and I put the substeps onto 2 constraint iterations to 200. And I believe I dive inside here. I've got a pop force, which is gonna create swirl noise, amplitude of 1, swirl noise, and only valid for the first 6 frames. So if $F is less than 6, be noisy. And then once it passes frame 6, this will become 0, which will deactivate this force. And then I did a pop attract, and I grabbed the centroid of the object merge, which is this, the object merge 1. So if I go centroid, and then this takes us outer level, outer level, outer level, outer level, and then object merge 1, which is outer level, outer level, outer level, outer level here, object merge 1, and I'm looking for the center of this object. And I do that in every single axis, so dx, dy, and dz, which gives us the center points. So if I ended up wanting to change that sphere around, it would always evaluate to the center of that object. And I've just done pop attract, and I left everything at default, which is just going to bring all these spheres up. It's going to try and bring all these spheres to the center point, obviously because there's a collision geometry in the way. It'll have them all kind of packed around the sphere. And I'm sure, as I've said that, some of you are going, well, you could just scatter onto this guy, and then there's your points. I can make that 100, and now I've got 100 spheres, and then I can do the attribute randomize here, which is going to give us the random p-scale as well. And then I can do this, also copy the spheres. Oop. And then there we go. There's our spheres perfectly around, but they're not actually perfect around. They're intersecting halfway. So then the last thing you need to do is you would need to do basically you want to push each sphere away from the surface, and you want to push it away by the p-scale value. So you can do that by, if I grab the normals, does have normal net. I grab the normals of the collision geometry, and I choose to point normals. Just untap that. We can see that we have normals, which is wonderful. And then if we do attribute transfer, we can transfer these attributes onto these points. So let's do in here. We have normals now on those points, which is great. And they'll still be intersecting. Last thing we need to do is do a point VOP. And inside here, I'm going to do a bind. We want to grab the p-scale. And then do a displace along normal. And we're going to grab the position. And we're going to grab the normals. And then we're going to do a mount p-scale. And if we put this now into position, watch the spheres. Whoop, each of them will now sit perfectly on top of the collision sphere. And then one last thing I'll do is I'll just do a multiply on the p-scale and just do a middle mouse button on this and go promote, and then it'll evaluate to 0 now. So if we do 1, it'll jump back out, and I'll just do a 1.02 or something, or 1.1, just so that they're not sitting too close, because then it might the vellum might stick, it might evaluate as inside, and then the points get stuck. And so just give them a little bit of space if you want to do this, and then you won't have to do this step. You'll see why. I kind of only thought about this afterwards, so I just thought I'd show you that. But what I did for this was not that. Give this time a second here. I thought to myself, I'll put them on the floor and then I'll pull them up, and then just watch it go. There's a bit, you see the noise is happening. They're all kind of getting pushed weirdly, which is great for the first 6 frames. Now they all start coming up. They're being attracted to the center point, but because of the collision, they're not, they're never going to get to that point. And then they'll just end up wrapping around the sphere, which is cool. Obviously, this other way is way quicker. As you can see, this takes a bit of time. So this you'll get there immediately. But what I found was it had some cool behavior when this side here came up and this side here came up, and they kind of smashed into each other at the top. It actually looked quite cool. And that could even just be a cool little effect by itself, having these spheres kind of crash into each other. But yeah, so that's what I did here. And then I just packed these. I packed the vellum, so you drop down a vellum pack, put the geo and the constraints there, and then I used a stash node. So I went to like frame 150 when things had settled, and I just pressed stash. And if I view the stash, it takes me straight there. And you can save this file and close it and reopen it. And because you've stashed it, it'll always, you don't have to restash it, it'll be fine. But if you do make any changes to your vellum, just make sure that you restash. Otherwise, you're not gonna, this will just read in the old vellum. And then I just vellum unpack. So I just drop vellum unpack down, put the geo in this side, the constraints in this side, and the collision geo into this one. And this is now just going to run a vellum sim from frame 150, which is great. And I think this is like same setup, no gravity, 2 and 200, and inside here, this is where we're going to grab the velocity field from the first flip sim. So dive inside here, I put down a pop-it vec by volumes, and I found that outvel Nell, which is outvel Nell. This guy here, the outvel, which is the velocity. We can see it there. Here we go. The velocity. It's a VDB, I think, but yeah, VDB. But it works for us. It just contains all that velocity information, and I can show it to you if you would like. You can do a volume trail, I think, and then I can do a box. And then just do a scatter. Oh, let's do a points from volume. And then let's just get this 02. And then points go in this side, and velocity volumes go in this side. Okay, and maybe we can put this sphere a little bit. See where, yeah, that should be fine. And then let's just drop this a little 5. Yeah. So if we view these, I think it's going the wrong way. Right. There you go. Just got to put vel in there, and then there you can see that's the velocity field that we are going to use to push the vellum around. Alright, so it's just this, it's our flip sim, but it's just the velocities, which is really cool. Alright, so that outvel over here, we're going inside here, and we're going to find that outvel. And I've left everything at default, update force, velocity scale I've put to 3, and that's it. And then pop attract, same pop attract, same settings, just so that it kind of keeps everything kind of attracted to the sphere. I'm like pointing at my screen as if you guys can see that. And so when we run that now, it's obviously going to run, it's running the flip sim, but if you've baked out that flip sim, you file cached it, then you won't have a problem. But you can see there, whoop, here we go, fluid hits the top, and the fluid is now pushing down the sphere, and you can see that it's going to push all these cool soft body spheres out the way, which is what you want. And it looks really great because they're kind of squishy and they kind of get pushed around nicely, and some will push. This sphere kind of falls on top of that one. It's really cool. So if you just watch this back now, poof, you see that. So it's cool. The impact kind of causes it to kind of jump up, but it's cool. Yeah. So that's that. That's the vellum. And then I do convert tets, which removes the inner 16,000 points, 18,000 points. Yeah, I think it just removes the inner faces of the tets because we've created the tets up here in solid conform. And then I do a collision source again, but this time we'll come back to this, but this is going to use the high-res particle separation for our high-res flip sim. so that our geometry, the VDBs of these, match the particle separation of the high-res FLIPsum. And the collision source here, and I think on the geometry I left everything at default. So over here you'll see we've got velocities on these points. Yeah, there's velocities on the spheres, which is wonderful. And we put two nulls for the Vellum Geo and the Vellum VDB. So there you can see the VDBs. Wonderful. And we will be using this as a collision inside of the high-res FLIPsum. So let's go do that. So I've got a final FLIPsum over here, and I'm just object merging in our out emitter. Remember from the beginning I said I'm going to grab the emitter, this guy here, and it's before I did the points from volume. So over here I do a points from volume, and I grab do a higher particle separation. So you can see now it's really a lot of points there. There's 61,000 points. And then the same thing, $FF on the jitter seed, jitter scale 1, and create a particles group. And then I'm merging in the VDB of the collider of the big sphere, and I'm merging in the VDB of the Vellum spheres. And I am putting down a DOPNet, and I'm putting the points into the first input, the bigger sphere into the second, and the Vellum spheres into the third. And then you can see the points from volume here. I've got 0.002, but I think you might notice that on the collision source it said 0.004. I've just done that points from volume times by 2. So this points from volume times by 2, which is 0.004. And then in the DOPNet, we'll go inside here, same setup, except this time I've got 2 static colliders, 2 static objects. Same expression, looking for the first path, and this one's looking for the second path. And on the second one, because it's moving, the Vellum is moving these spheres, I've just ticked use the forming geometry, and this reevaluates SOP to interpolate geometry. It'll just look at every subframe as well if we have any subframes on our flip solver, which will give us some nice behavior. Volume sample, same thing, 2, and on this one, volume sample 1. You can actually put volumes into the SOP path here. I realized that at this point. That's why over here I put in geometry and I put in volume, but you can just put in the volumes. It understands that totally fine as long as you have volume sample on the mode over here. And then I think it's the same setup here. I've just got gravity on, merging these guys in. On the flip object, I've just copied and pasted that particle separation, so 0.002. Particle field, removed that property, put this to particles, physical. Density I've done 250, and viscosity I've done 10 for the high-res FLIPsum. That was just by playing with some values and getting those right. And then volume source, same thing. First context geometry, flip source flip, and does the rest for us. And then on this, I've done substeps 2 and 3 for the flip solver. Volume motion, reseeding, I've done reseeding and I've oversampled by 4, and I've changed the depth threshold to 2. The oversampling I think is 1.5 by default, yeah. And if you just crank this value, it'll just push more particles into your sim. And the more particles you have, when you're doing your meshing, the better results you'll get. So less flickering, and you can smooth things, you can take things further for your smoothing if you've got more information. So you can crank that as high as you want, but I found 4 worked for me. And then this will it'll tell the sim when to kill. Particles will be deleted, from a voxel once the current number rises above. And so I just played with that a bit, and I found 2 worked well for me. Separation again. This works nice for the meshing, keeps the points nice and evenly spaced. And then on the volume motion again, swirly kernel, change my volume limits, viscosity enabled, and surface tension I've enabled, and I've put the surface tension to 0.1 this time around. I think because I have a lot more points and I have more substeps, I think I found the more points you have, I had to dial this value down. If you noticed on the previous one, the low res was at 1 and it was fine. If I put it on 1, it kind of tends to freak out a bit, so I had to just drop it till I found that it was fine. So 0.1 works well for me. And that's the high-res flip sim. And just got to let that cook. So again, put down a .io, I drag in the .net over there, and then find the flip object, Control C to copy, over here, Control V to paste, and just from the presets, just choose flip fluid. And then you got your flip fluid only, which is great. And then again, fluid compress that. I just put in the particle separation of the high res, so this one here. Put that in here as well. And then leave everything at default and drop down file cache. And just put that over there and just save it out to a file path of your choice. And then for the meshing, I just did a fluid surface, particle fluid surface node, which is pretty. For this, I didn't need anything fancy. I didn't need a fancy VDB workflow, so I just did this over here, and just put the particle separation to be the same size as my sim. And surface polygons, adaptivity 0. I think it's a 0.005. Yep, I think I just put it down to 0 so we get the most amount of mesh out of it. If you have adaptivity, it could flicker the mesh because it tries its best to, in flat areas, it keeps the mesh quite low res and then only subdivides in like the curvy areas of the mesh. So putting this to 0 will make it like a high res all over the whole mesh, which helps when you comes to smoothing. You don't get as much flicker. And then on the filtering, I did a dilate of 4 and a erode of 2. So and then mean curvature. So when you do, I'll just show you this. Put down one of these, and we go to filtering. If I activate the dilate, this will automatically activate as well because they're linked. So what I do is I usually just delete these connections. I did that with Control Shift left click. And then I usually kind of go 4 dilate and then erode by the lower number 2, so that it keeps it a little bit thicker, because then I like to really push this smooth quite a lot. So I think in my meshing, I did a smooth of 50. So you dilate it, this will do a dilate on the VDB, so it pushes the VDB out, and then we smooth it a lot, and then I erode it by 2, so I pull that VDB down again by 2, which kind of gets it to a similar space that we had the particles, and then I do a final smooth, mean value smooth of 2 as well, and that's then also file cached out as the mesh. And then you can use an alembic output drop and just save out the frame range of an alembic file of your mesh, which we can then import into Blender to do the lighting and rendering. So that concludes the Houdini side of things. In part 2, we'll check out the lighting, shader creation, and rendering in Blender. I'll have all my alembics already imported, and I'll walk you through my materials and my lighting and my rendering settings. Thank you so much. And if you have any questions, please write to me in the comments and I'll try to get back to you, and see you in part 2.